Hi, welcome to the third uiZ tutorial. I've taken the example from the first tutorial and showed it on screen here. Remember, we positioned this square at 100 by 200 pixels. Now I'm going to explain what this px means. This px stands for pixels, but we can actually fill different types in here. For example, we can fill in dp, and that's gonna look different. In fact, I'm going to have to change my parameters here. Now look, this looks actually about the same as our last example. So what does this dp mean, and why did I change 100 to just 1? It all boils down to this picture. As you can see, we have a computer here and we have a phone. If we were to define pixel values, so let's say we have a button here that is 300 by 50 pixels, it would be okay to press on the computer. You see, these buttons are relatively small in my browser. However, if I had the exact same picture on my phone, it would be almost impressible. So therefore we need density pixels. That is a way to say this object has to be this size or at this position in inches. So 1 dp is actually equal to 1 inch, or roughly. dp isn't always perfect though. Sometimes through hardware, software or configuration issues, the dp values can be a little bit off, but in general they are pretty reliable. So let me show a real life example now. If I now also change the size to be in dp, as you can see on this picture, the square on my phone and on my monitor are roughly the same size, even though the monitor is at the same resolution. So using pixel values, the square would be way smaller on my phone, but now it's physically the same size, even though in pure pixels the square on my phone is now bigger than that of my monitor. So now we can move on to something called FC. FC stands for factor. So you can imagine that my screen is several hundred pixels wide, my window. Now let's say that the entire width is equal to 1 FC, 1 factor. Then half of my screen is equal to half a factor, and a quarter would be right here, a quarter factor. And I can show that in code. Look, if I say 0.5 FC by 0.5 FC, then you can see that our square is now in the middle. Well, at least the top left part is. So that is the power of FC. And we can also apply this to our size. We can say 0.5 FC by 0.5 FC, and then maybe we place this on .25, and now we have a square in the middle, like this. Now the nice thing that I can do is I can now drag the window, and you can see that the square changes its size. Neat, right? This also works with parents, so if I were to put this square inside a different gradient square, then the square would use the width and the height of the parent. I will show you. Okay, I've taken another example. This looks a lot like the one in tutorial 2. So we have our gradient here, and inside of the gradient there is a square. The square is at position 0.3 FC by 0.6 FC. Let's see what happens. Okay, great. So it is right now, it's at 0.3 FC by 0.6 FC. Notice that 1 FC is now not the entire width of the window anymore. It is just the width of the parent, because we put our square inside of the gradient. To the square, 1 FC is now equal to the entire width of the gradient, or the entire height of the gradient. With this example we can also move our window, but it's not gonna affect much, because, well, the actual size of our gradient stays at 200 pixels by 200 pixels. So next up I'm going to talk about uiZ snap. We have snap left, snap right, snap top and snap bottom. What is special about this is that unlike px, fc or dp, the normal position values can't be used. So if I enter 0 here or enter 2 here, it's not going to do anything as long as my position type is set to uiZ snap. So because this number doesn't actually do anything, I'm just going to set it to 0. See? Right now a square is snapped to the left of its parent. I can also snap it to the bottom using uiZ snap bottom. And again, I'm going to set this value to 0. And like that, our square is now at the left bottom. In cases like these, where you have this 0 here and a 0 here, because you're using snap, you can actually use uiZ position underscore t. This completely removes these arguments. This function is actually also useful for the next position type you're going to look at, which is uiZ center. As you could have imagined, uiZ center is going to put the square in the center of our gradient. Now last up we have uiZ fill. Now what is so very special about uiZ fill is that it disables our size. Look, we provided the size of 50 pixels. However, uiZ fill filled our gradient scale nevertheless. So this value here doesn't matter. We can therefore replace the uiZ size function with uiZ size underscore h for height. And then we can remove our x arguments. This provides the exact same result as before, but with a little bit neater code. So that was the tutorial. I hope you learned about how TP positioning worked, how FC positioning worked, how pixel positioning works, how uiZ snap works, how uiZ center works, and how uiZ fill works. You will use these types a lot when using uiZ.